All right, so today we're going to take a look at the sine law. And to get started, we have to talk about the way we were going to name these triangles from now on. And it's always the opposite side that's going to help link these things together. So for example, if you're here at angle A, then straight across to here, we would name this little a as in side A. Okay, same thing if this is B, then we would name this side B. And if this one is C, then we would name this side C. That's just the convention that we use to make it easy for you to know which sides we're talking about. The side and the angle are directly across from each other. Okay. So I'm going to show you guys what the sine law says, and then I'll show you how you get that formula. So first of all, we'll go take a look at the sine law. So someone's done one of those GeoGebra worksheets you guys have done. And what this is the three angles in the triangle. See here it's saying side A, which is this one, divided by the sine of A, which is this angle, is equal to 12.12. If we do that for B and C, we get the same things as well. So if I move these around, those numbers can change. Like for example, it's 13.8, 16.1, but they all end up, no matter what the triangle looks like, the ratio is the same for all three. So the side divided by its sine is going to be the same all the way through the triangle. Okay? So let's take a look at how you actually get that. So let's just say this was our triangle, and I'm going to call this H for height. And then we're going to have to name it so we can talk about the pieces of this triangle. So this is A, B, C. It wouldn't matter how you named it. If you named it differently, that's fine. But we want to be able to refer to these pieces. So the first one here, which side would I label this? Good. Nice to know that we're awake this morning. And I'm going to label the side directly across here as C. And what I want you to think about, you don't need to do this in your set of notes, but I want you to just think about, maybe I'll switch to a thicker pen here. I want you to think about this purple triangle that I'm going to highlight. And this green triangle that I'm going to highlight here. So well, I guess it wasn't yesterday, but last lesson we were dealing with right angle triangles, right? The big triangle in this picture, the original one, is not a right angle triangle. All the angles are different in there. So what do we do then? We can try and take that triangle that we don't know anything about and make two right triangles out of it, so that way we're using the information we had in last class. So do you notice anything that they share? Anything similar between the green and the purple triangle?
They all have the same amount of sides.
Same amount of sides, yeah. All triangles have three sides. Yeah. Yeah, the height is the same for both those triangles. So that's what we're going to do to figure this out here and get the sine law out of the problem. So what I'm going to write on this side is I'm going to say the height. So for the purple triangle, actually I'll write it like this for you. The sine of A is H over C. That means H is C sine A. Okay so far? We'll do it one more time, and hopefully it'll sink in on the green triangle. So if I'm looking at the green triangle here, what will be the sine of C? The sine of angle C, yeah, H over A, that's right. So H is the A times the sine of C. So here's the thing, is we have two different ways of writing down H, and that's how you end up using them to get the sine law. So if H is equal to both of them, then I should be able to rewrite it like this. C sine A is the same as A sine C. Because both of these are just, this is my purple height, and this is my green height. Now what I'm going to do is I'm going to divide out so I have C on one side and A on the other. So to do that, I'll divide this triangle here by sine C and move to the other side. So I'll end up with C sine A over sine C equals A. And then I'm going to move this last piece. Last day we talked about a shortcut, which was to do the cross multiplying. So C would go to this side and A would go to this side. That's what we're going to end up with when we're done here. But just doing it step by step. So if I divided out the sine A, I'd have to do the same on this side. So the last thing I'd end up with is C over sine C is A over sine A. Now the algebra doesn't always make a lot of sense when you see the algebra, but let me show you. I'll give you a minute in case you're still writing it, but remember what it's saying is the ratio for the side and the sine of the angle will be the same all the way through the triangle. And I'll show you the worksheet again in GeoGebra to see that. I'll just give you a second to copy that down. I'll update that in case that's... I was trying to show you where it came from, but that really wasn't there in the actual problem. It was just that... I guess it'd be better if I rewrote it like this for you. Let's see. This is the height here in purple, which corresponded to this one. I'm just trying to show you where it came from. And then this is the height that came from here. So that's how I know that they're equal, because they refer to the same height. All right, so let me just show you one more time then. What it's saying is no matter where I move these points, I can change the way the triangle looks, and those ratios, 16.16, it's the same all the way through for the three angles and the three sides. 13.18, 13.2, wherever I move it, I still end up with the same ratio all the way through the triangle. Okay, so that idea is going to help us solve some problems that we wouldn't have been able to find before, because we come across problems when we don't have a right triangle, and we wouldn't be able to solve them until today. So let's just see if we have, I guess it's not really well written in there, so I'll just, this is 14 degrees here. So if you're copying it, you can copy it in like that. And I'll walk you through the first one just so you can see the way it works. And then we'll talk about how we could find these ones, and we'll use the sine law to do it. Okay, so the first thing that what I do when I come across a question that's sine law. Now the good news for you guys is if there's no right angle in the triangle, we're only going to have two ways of dealing with that. This is one of them, and then your next lesson we'll talk about the cosine law. So basically if you don't see 90 degrees in there, you're going to have to do one of these two things. And what I usually do is I start the triangle by doing a crisscross. So what I do is I say these ones are pairs because they're opposite, and these ones would be pairs because they're opposite. So now I know who's partnered up in the sine law. I could write this out as 29 over sine of B is equal to, oops, sorry, did I, one second here. Yeah, I paired an angle up with an angle. My apologies. It should be the side there, yeah. So it can still be an arrow that goes there, but it shouldn't pair up with 75 degrees. That's side C. Sorry? It has to be this angle in the corner or we won't be able to solve the problem. You know what? Let me do this then. Let me do this just so that we don't get... I'm just going to draw the triangle bigger so that it's clearer, okay? Because there's some issue here. Obviously, it's not very clear. It even fooled me, so this one would be 75 degrees. This would be 29. And this is A, B, and C. So, again, my apology. I had a computer program draw it up, and it didn't do a very good job of that small triangle. The other ones look better, though.
Wouldn't 75 have to be in the
Yep. Good point. Okay. So we're still going to draw that crisscross, but now I think this one here, and let's see here, it'll be this one here. So they're partnered up. What's the missing angle there that we don't have?
B.
Yeah, B is the one we don't have. Does anybody know how much that angle is going to be worth?
Yeah, it has to equal to 180 minus 14 to 75.
Good. 180 minus 14 minus 75. So let's see here. So it's 91 degrees. So if we use the sine law, we can pair these things up. Now, one thing is there's 4 pieces in the sine law. You can only solve it if you have 3 out of 4 things. You have too many missing pieces, you won't be able to solve the equation. So when we pair these things up, we could figure out, for example, these ones have a complete pair. So I definitely want to use these two because I already know the answer for both. So this is going to become 29 over sine 91. And I could find either of these sides, A and C. So which one do you want to find, side A or side C? A was yelled out first, so let's find A. Oops, sorry. I just hit the button, my mistake. So this would be A over the sine of 75. Okay, so A and 75 are the pair. So as I said before, you have 4 things that you need to have. So you need 1, 2, 3, 4 things. We have 3 of those, so we're going to be able to solve it. So I'm going to rearrange this for you. Yeah, that's going to go up to the top, which is probably something that from the practice I gave you last day, hopefully you're getting the hang of. This will be 29 times the sine of 75 over the sine of 91 is going to be the length for side A. So we'll calculate that, yeah, and we'll find the length that we're missing. Okay, so let me see here. I'll enter this in as 29 times the sine of 75 over the sine of 91. Okay, and just should make sure I'm in degrees. See, right now my calculator isn't. It needs to be down here in degrees. So make sure yours is too. And it tells me that side is 28. Okay. And that should probably make some sense if you were doing this question, because these 2 sides here look fairly similar. This one's going to end up being longer, the 29 inches though, because the angle across from it is bigger. You had a question?
No, it's okay.
Figured it out? Okay. Okay, so let's take a look at this one here. Here's my pair. That was better. Smoother anyways. So all I want you to try is write up a sine law equation. Don't try and solve it yet. Just see, can you write up between those 2 pairs a sine law equation? Okay, so the connection that you can make here is it goes 9 is paired up with the sine of 87. And that has to be the same as if I lined up this side here, B to the sine of 51. Okay? So the pairs get lined up. Those pairs are equal. Now I can rearrange my equation. That'll go across. So I have 9 sine 51 over the sine of 87 will be the length of B. Okay, so 9 times the sine of 51 divided by the sine of 87. So that length would be 7 miles. Okay, so now try doing the last triangle. One of those, see which is missing in your pair. Just see if you can start by figuring out who the pairs are in this triangle, okay? We'll continue once we find the, anyway, start. Who are the pairs in this triangle? Yeah. So the two pairs you should have marked in your page, here they are, across from each other and across from each other. So when I look at those pairs, I'm missing something, and this time it's an angle. So yeah, Tim, you're right, it's going to be in degrees that we're looking for this time. But before we do anything, we're going to start like we normally do and write an equation. So see if you can do the equation for it. All right, so what you should end up getting then is that if you pair these up, you'll have 27 over the sine of, 57 is equal to 26 over the sine of C. Now what we can do is we can rearrange this formula to try to figure out our missing piece. So we're going to have a lot of pieces to move around here. We'd have to get this sine angle C up to the top. We're going to want to move this, well, maybe we'll just do one at a time. So I get 27 sine C over sine 57 is 26. And this is the piece that I'm trying to work my way to having it all by itself. So I'm going to move everything else out of the way. So that means I'm going to end up moving 27 across. And then finally, the last piece I have to move is from the bottom up, so sine of 57. So the last piece I'll have is sine of C is 26 over 27 times the sine of 57. So I'm going to start by putting this in my calculator to work this out. So we'll get a decimal value here. So this is 26 out of 27 times the sine of 57. So what I end up with here is 0.0. I'm going to take 4 decimal places. So it's 0.8076. And you have to be careful when you're finding the angle, though. Does anybody remember what's the difference between sine and sine inverse or sine negative one? Do you remember what the difference was? Yeah, this one gives you an angle, right? Yes. This one gives you a ratio. Yes. So in this case, this is telling us the ratio for angle C. But we don't want the ratio. We want to know what was the angle that we started with. So the way you would rewrite it is C is the inverse sine of 0.8076. So this time I'm going to have the inverse sine of 0.8076. So the actual measure of this angle is 53.9 degrees. So one tip that I'm going to give you that'll make life easier for you when you do this, these fractions that you're dealing with, if you have a sine law, there's 2 ways you could write the sine law. So the sine law for sides if you're trying to solve for a missing side, you want the sides on the top of your fraction, because what that means then is when you go to rearrange it, you'll probably only have to move one piece. We could do the same thing then, the sine law for angles. you don't have to remember both ways because it works, it's just a little bit more work, is to put the angles on top. And that way you will have to do less rearranging of your equation. You would have been able probably to skip most of these steps in the middle here if you would have used this other form, okay? So I'll try to remind you of that as we practice the sine law again. But if you're looking for an angle, put your angles on top. If you're looking for a side, put your sides on top. That way you'll be less to rearrange when you're done. Yes, Tim?
Can't you use the first one too, for the angle?
Yeah, you could use either. In either scenario, you could use those equations, but it's just going to be a strategy to get your work done quicker. So yeah, you only need to know one way, but that makes life a little easier. So okay. So this time I'm going to have you practicing. The angle tends to be the tricky one. So see if you can figure out the pairs, the equation, and what the missing angle is. Now maybe I'll just remind you one more time, this is probably the way you're going to want to try writing out the equation to get the angle. It'll just make your life a little easier to solve it. Okay, so sine of the angle on top since you're solving for the angle. Okay, I want to walk through the first one with you. It looks like quite a few people are getting an equation, but maybe working it out is getting tough. So this is the pairs in this problem. So what I'm going to do with these pairs now is write an equation. The missing thing is angle C. So I'm going to leave my angles on top because that's what I want to solve for. So I'm going to have sine C over 12 is the sine of 56 over 29. Okay, so that's my equation. You could have your equation flipped. That's fine. What we should all end up with is the sine of C is 12 sine 56 over 29. So no matter how you approached it, we should all end up at this spot right here. Okay? So this is where I said this here is going to give me a ratio. And we want the angle. So that's why you got to remember, use the sine minus 1. So let's figure this out in the calculator. What's the value of 12 times the sine of 56 over 29. So that's 0.343. Oh, is that not? That's right, okay. Yeah, so now this is my ratio that I've got. Right? These two are ratios. I want the angle, so you have to use sine minus 1, the inverse sine, and that'll tell us what the angle is. So sine minus 1 of 0.343. So 20.1. Okay, so the next two triangles there, I'll let you walk through those and we'll review them together as well. All right, so here's the pairs. This angle is straight across from this side. This angle is across from this side, side B. My missing thing is a side. So because I'm missing a side, I'm going to leave the sides on top of the fraction. So that would be B over sine 23 is 34 over sine 108. Now it's okay if your fractions were upside down. It just means you have more work to do. All I need to do is move sine 23 up. So I'll end up with B is 34. And once I move that up, well, it's easier when it's on top because then you've usually only got one item to move around. So this time I have 34, then sine 23 divided by the sine of 108. So it's roughly 14. Let's call it 14, 13.98 or whatever it was would be fine as well. So this side here is 14. 13.9 is fine as well. Here, let's see what did it round to. 9.7, that's fine. Okay, so the last question there again, what are your pairs? Can you write an equation and see if you can go all the way to solving it this time? Okay, so here's your pairs. Your pairs are straight across
Oh, we're not even doing that anymore.
and straight above. What I'm missing is an... Thank you. What I'm missing is an angle, so I'm going to rewrite it with the angles on top. The sine of 69 degrees over 35 is the sine of angle B over 27. So then if I rearrange this, all I have to do, because I put the angles on top, is move 27. So 27 sine 69 over 35 is the sine of B. Now remember, that is the ratio. It is not the angle. So once we get this number, we have to put it in the calculator with the sine minus 1, the inverse sine. So I have 27 sine 69 divided by 35. So 0.7202. So I use this to then give me the angle. The sine inverse of 0.7202 is equal to angle B. So that'll be the sine inverse of my answer there. So it should be 46.1 degrees.
46 is okay.
Yeah, 46 is okay as well. Okay, so can I see if we're getting a hang of this? How many people in those last two examples, side and angle, how many got at least one of those two? Excellent. How many got both? Good, okay. So it sounds like one part of this unit that we're going to be working on is the some problems. So we're going to try a couple here together using sine law to do it. But I'm telling you, honestly, the skill involved here is fairly low. It's a skill which basically requires you to translate the English sentence into a sine law problem. Once we have the problem translated, it's just the same as everything we've done before it. So let's take a look. It says, Toby uses chains attached to hooks on a ceiling and a winch to lift engines in his father's garage. The chains, the winch, and the ceiling are arranged as shown. Toby solved the triangle using the sine law to determine the angle that each chain makes to the nearest degrees. He claims that this one here is 40 degrees and that this one here is 54 degrees. Do you think he's correct? Yeah, so what you can do is you can check to see that he's done his calculations properly and see if he's correct. So your job is to figure out what those two angles in the corner make. So use your sine law to do it. Okay, so what did you guys find? He's correct? No?
It wouldn't be correct or it wouldn't be a question.
Well, let's try and verify it, okay? Let's say that we want to pair these guys up. Well, one that we should always be using is this one here, because that one we're going to assume is correct and that the other two could be an error. So to pair them up, here's my first pair that I want to check. All I'm going to check is, we don't even need to do any solving here. I'm just going to check, is the sine of 40 over 2.2, and I'll put a little question mark over my equal sign, meaning I'm just testing it out. Is that the same thing as the sine of 86 over 2.8? So let's see what the calculator tells us. The sine of 40 divided by 2.2 is 0.2922. Now we'll compare that with the other side, which says the sine of 86 divided by 2.8. So that's 0.3563. That's right. So those aren't correct. So this angle is not 40 degrees. Okay, we could go and find the actual angle itself, but in this question all we have to do is say, could that be the angle? And the answer is no. Now what about 54? Could he be right about 54?
It's obviously wrong
Why is it obviously wrong?
because
That's right. So we could repeat this process. We could check. We could say, well, is the sine of 54 over 1.9 equal to the sine of 86 over 2.8? We could check that, but why would we do all that work again? Because what Toby's done is 54 plus 40 plus 86 is the whole 180 degrees in the triangle. So if this one's wrong, then it wouldn't have added up properly here either. If you think about the way most of you probably would have answered this question, you'd go 180 minus 86 minus 40. And if this answer is wrong, then the answer that you're going to get is wrong. It's not 54 either. But either way, you could do this as your explanation. You could use the sine law and show that the sine law is false here, meaning it doesn't work, or you could explain it with the 180 degrees of the triangle. All right, so the last question here, a small problem for you to think about. And again, if you're not one who wants to write down the words, then you at least need a picture on your page. Yeah, it says the captain of a small boat is delivering supplies to 2 lighthouses as shown. His compass indicates that the lighthouse to his left is located 30 degrees, north 30 degrees west, and the lighthouse to his right is located north 50 degrees east. Determine the compass direction he must follow when he leaves the lighthouse B to head for lighthouse A. So first of all, one thing you should notice here about this system that they use for measurements and direction, the way you read that is, if this is your compass and you have your directions on it, this means the boat is going north but 30 degrees to the west. So this is what it would look like here, is you're headed north but then you move 30 degrees to the west. That's how you get this side right here. Okay. The other direction says north but 50 degrees east. So that means this time he's going 50 degrees to the east, and that's how you get this line here. Okay, that is the convention in your textbook. You will see that used again for your directions. So what you're trying to figure out here is, if he's doing this, determine the direction. When he leaves lighthouse B, he's going to go this way. What's the measurement he has to go? So one way you could do this is, if that's north, how far west is he? Right? You could also do it, what's this angle in here? There's a few things you're going to need to do. I'll give you one hint. Do you guys remember what this is?
Height. Separate.
Do you remember what the purple line is? What is it? Yeah, they're Z angles. So what's the angle in here? So anyways, give it a try, see if you can figure out what bearing he should be on. The first thing you should do if you're having trouble looking at the word problem in the diagram is remember that if you're going to be using trig, maybe you should just focus on a triangle. So I'll redraw this in my margin here. And this is 9 kilometers. This is 12 kilometers. What's the angle down here? Yeah, it's 80 degrees. And this is A, this is B, this is C. So which angle am I looking for? Yeah. So now that problem does not look nearly as scary as the word problem. The ones that I would pair up here are the ones directly across, and look at that. It's ready to go for sine law. So try there. That should be a mega hint for you to get this problem off the ground if you haven't already, okay? So solve for the missing angle, and then we'll see if we can come up with his bearing. Okay, so the angle we're looking for means I'd like to put the angles on top to make life easier when I solve this. So sine b over 9 is sine 80 over 12. And if I rearranged it, sine of b is 9 sine 80 over 12. And that's going to end up becoming 9 sine 80 over 12. So I get 7386. But remember, that should not sound like an angle to you. That's a very tiny angle. That's the ratio. So what we have to do to get the angle is put that into here. And then we'll know what the size of that angle is. Yeah, that sounds right. Let me just put it up on the screen for people to see. So 47.6 degrees. Let's call it 48 degrees just to make life a little easier. So in my problem, this is 48 degrees. I'm going to transfer it back into this messy looking word problem. 48 degrees. So can anybody figure out then, what's this red angle that I marked earlier?
81.
Yeah, it should be 82 degrees. How did you guys get that? Yeah, so you have 180 on the line, and you take away 50, take away 48, and you end up with 82 degrees. Yeah, so you could figure out this angle up here as well. But the one we're looking for is the captain's bearing. So if that's 82 degrees, one way we could write this is north 82 degrees west. Some of you might be thinking, well, you're basically traveling west at that point. So what I could do is, I could also, it would be correct if you thought of it this way. If I put 90 degrees here, there's 98 degrees between 48 and 50. So if I take 90 out, there's 8 degrees left there. So that way I could also write this as west 8 degrees north, and that would be acceptable as well. I'd know what you meant. Okay, either would be fine in this case. So for tonight and the rest of the block anyways, this is the homework I'd like you to work on. It's numbers 1 to 13 and 15. We will have time to talk about this on Thursday, so I will not be collecting it at the beginning of the block. We will talk about it in tutorial on Thursday.